Hi, I want to discuss other coaxial type tolerances. Okay, so two or more coaxial features tolerance relative to one another. Okay, so one coaxial feature is identified as a datum feature. Others applied positional tolerance referencing the identified datum. Okay, so what we have here, we have a drawing of this workpiece. We have two concentric diameters here. We have a diameter of 1 in 5 thousandths, plus or minus 5 thousandths. That feature of size is datum A. And then we have another concentric diameter here, 567 thousandths plus nothing minus 5, with a 5 thousandths true position at MMC to A at maximum material boundary. So what would the functional gauge look like for that? Okay, so first of all, this gauge would have a diameter here that's sized at the datum feature MMC boundary. Okay, so that would be the max shaft, which is 1 inch 10 thousandths. And then we have another hole, which is concentric to that, which is sized to the virtual condition of the feature. In this case, that's 572. Okay, so the maximum material of this condition of this diameter here would be the 567 plus 5 thousandths true position. That gets me to 572. Okay, so I would put this part into this gauge as long as it was to fit, then everything would be fine. And the part would meet that coaxial tolerance. Okay, let's talk about radial hole patterns. Okay, so in this part here, we have a diameter, okay, with holes passing radially through this diameter. Okay, so the axis is passed through the center of a circular shape. The tolerance zone framework is centered on and perpendicular to the primary datum axis. That's this composite axis that's made of datum A and datum B. That's this composite axis here at MMC. And holes may move independently within the tolerance zones. What does this mean? Okay, so the tolerance, if you look at it here, the tolerance is specified as diametrical. Okay, so in one direction, the tolerance for the location of these holes is relative to datum surface C. And then what is the tolerance in the other direction? So the tolerance in the other direction would be this 20 thousandths diameter, which is centered on these holes being 90 degrees from each other. So what this does, it sets up a tolerance zone framework like this, where we have a diametrical tolerance zone of 20 thousandths. It's centered on the true position of the location of the tolerances for plane C, and it's located on datum axis AB. So essentially that's what this feature control frame means. 20 thousandths diametral at maximum material condition, and that's how we would check it. Okay, so let's talk about symmetry for a minute. So symmetrical position. So symmetry is a condition where features on each side of a center line are equal. So position and profile tolerances can specify location accuracy requirements. Feature control frames formatted the same as position tolerance specifications. Symmetry used to be a symbol. Now let's talk about this for a second here. There was two past practices prior to GDT 2018. One of them was symmetry and the other one was concentricity. Okay, so what we would do with symmetry, we would do something like this. If we had this feature, it's like a T-bar, okay, so we have one width is 600 thousandths, the other width here is 375 thousandths, and then we put this symmetry on that. Yeah, so nowadays you can really, they did away with the symmetry feature, the symmetry characteristic in GD&T, because you can do the same thing with a positional tolerance. So you're controlling the positional tolerance of this 375 width to this 600 width. Just set up the 600 width as a datum and put a positional tolerances in there. So that's how that works. And then you can use modifiers when you put this positional tolerances that give you more flexibility than symmetry had. Symmetry was an MMB condition. It was strictly applied at regardless of feature size. The position tolerance, where we could use different modifiers regardless of feature size, or we can put the MMC modifier or the LMC modifier. It gives us more flexibility, and we don't really even need that symmetry call out. And it was the same thing with concentricity here too. I showed you how to dimension coaxial features in this previous slide. Let me go back to it, talking about how to dimension these things to the previous slide. And what we used to do is we used to use concentricity for it. Now the concentricity, again, kind of like with symmetry, that was always applied at regardless of material boundary, regardless of feature size. Okay, so what we did is we're going to use true position here, and then we can specify it regardless of feature size, regardless of material boundary if we wanted to, or we can specify that using the MMC modifiers if we wanted to. So again, these past practices of symmetry and concentricity have gone away, and really true position or the positional tolerance features that we've been talking about in this chapter and last chapter too, can do exactly what those old features, these old functions could do, these symmetries and concentricities. So they've been eliminated at GDT 2018. Okay, that's the end of this lesson. Thank you.